Dalton said the atom is a solid spherical particle like a billiard ball. Next, Thomson proposed a model in which electrons are distributed like raisins in protons. And Rutherford insisted that the electrons circulate around the protons like the planet of the solar system. Bohr's hydrogen spectral experiments have suggested that electrons can exist in certain energy regions around protons. If we look at the hydrogen atom in this Bohr model, Coulomb force between protons and electrons F equal Q1 Q2 per 4 pi epsilon 0 R square, and it is minus Q square per 4 pi epsilon 0 R square. For this time, epsilon 0 is permittivity in free space. Work is multiplied by the distance and force, and its unit is joule. This is also same as the unit of electric potential energy EP, so it can be expressed as F equal minus delta EP. The amount of change in EP is equal to the change in distance to force. Integrating both sides from an infinite distance, EP minus E vacuum is 0 minus Q square per 4 pi epsilon 0 R. And because E vacuum is equal 0, EP equal minus P square per 4 pi epsilon 0 R. There are three types of solid-state material: crystalline, polycrystalline, and amorphous. Crystalline is a structure in which atoms appear perfectly periodic, and polycrystalline is a regular but interrupted structure. Finally, amorphous is a completely irregular and unstable structure. And there are also three cubic lattices. Single cubic is a cubic with atoms and at each of the 8 vertical of a cube. Body-centered cubic is a cubic with 8 vertical of the cubic and 1 atom at the center of the cubic. Face-centered cubic is a cubic with 8 vertical and atom at the center of each face. And at this time, the application of FCC can obtain diamond lattice. Finally, there is a way to represent the plane and directions called Miller indices in the cubic structure. If you cut the plane, the x, y, and z coordinates are expressed as 1 or 0 in the normal direction perpendicular to the plane.